Hello and welcome to part 4 of the event-driven programming. You are ready for this tutorial when you've got your program for the ticket machine basically working. So you've got rid of syntax errors, the program runs, might not be fully perfect yet. That's when you're ready for this section. So learning outcome 2 is about refining the program to improve the quality of it. Basically, I've shown you some code examples along the way, and some of them are a bit stripped down, and there's more we could do to ensure a really solid program that's going to work without hiccups. So one of the first things we want to tackle in outcome 2.1, it's about naming comments and code layout. And this is everything you learned in the software development unit about good programming technique. So the main points were, as I'm sure you'll remember, we're using white space well, using sensible variable names, and in particular avoiding single letter variable names, using lots of internal comments to describe what's going on, and using comments at the start of every function or procedure to describe its purpose. If you do this consistently throughout your code, that's what's looked for here, and that will help it to become habit with you, which is a really good habit to have as a programmer. Outcome 2.2 wants us to define user functions to replace repeating bits of code. You need to review your ticket machine program and see if there are places where you have similar code or code that's achieving a similar thing. You could then consider whether you could have used a function for this. The example we saw along the way was the display banner function. It will simplify your testing if you're able to do that. So that's looking for any repeated code, pieces of code that you can turn into functions. Outcome 2.3, they want us to validate the data that's input. So there are a number of places in this program where we need user input. We should check each time that we've got what we expected, and we should reject the input if it doesn't meet our expectations. An example would be at the number of stages of travel. So we can accept 3, 6 or 9 as the number of stages. There's also the hidden management function with where the user can enter M. So 3, 6, 9 or M are the only inputs we can accept at that stage. Anything else is invalid. Another example would be when you do go into the management function and the manager has to enter the specific PIN. Only that actual manager PIN of 9900 can be accepted. Anything else is invalid. And you need to give the user prompts which will help them get it right and help them understand what they've done wrong when they don't get it right. So 2.4 is about error handling, and what we've just looked at, the validating of input reduces the need for error handling because only sensible values get through. So we don't have to deal with crazy values coming into the main processing of the program. So this leaves file operations as the main area for handling possible errors. For example, what if ticketprices.csv is not there? Then your startup routine is going to fail. And what if ticketsales.csv fails to write? Then your shutdown will fail. You can use a structure called try except for this, which we'll see on the next slide. And what you do is you wrap the file open and the actions that go with it in the try part, and you wrap the message to the user and a suitable follow-up in the accept part. In other words, you wrap what do you want to do when things go wrong in the accept part. So let's take a look at that. Here's a startup routine that you saw before, but this is it with try except implemented. So we begin the startup routine, we declare our arrays, and then we open the try part. Inside there we've got file open, reading the file and processing each line that we went through in detail before, and then we create the class for ticket sales, which stores the data that will get written out on shutdown, and then we display the welcome screen. So that's all the things that we want to happen. Now we reach the except part, and we have to specify what exception we're dealing with. In this case, it's a file not found error, and you can look up Python errors and see a list of all the ones that are recognised. So what happens when the file is not found? We want to put a message on the screen, explain to the user what's happening, and we want to quit startup. So that's how try except works. Put try, put all the things you want to happen, then put except, give the error name that you're covering, and put in the code that you want to happen when that exception occurs. So you can improve the quality of your program by wrapping your file handling sections in that kind of code. Remember to check all your file operations, and remember to think about how your program will progress after the error occurs. For example, if that happens on startup, does it even make sense to enter the main loop? It probably doesn't, because your prices will show on the screen as 0. So that was learning outcome 2, which was all about quality. So now your program should be proper quality. So we're moving on to learning outcome 3, which is about testing. So we're looking at page 13 of the workbook, and it gives you quite a bit of detail on how to use the debugger. So I would recommend that you read through that. This is for the stage where you have overcome all the syntax errors and your program is running, but it maybe doesn't operate as expected. So perhaps it crashes, or perhaps the flow is not right, or maybe the output's not right in, for example, the ticket sales file. So I would suggest that you take a look through, that's page 13 and 14. Should help you get fluent with using the debugger. It's not the most intuitive one, and there is a link to a YouTube video as well to help you. After that, we are looking at preparing a test strategy. So basically, when you've got your program working, as in you can give it inputs and get expected outputs, then we want to test it really thoroughly. I would recommend that you read page 15, which just explains module testing versus integration testing, because you've probably not produced a project quite as big as this before, and it's good to be able to test your subroutines individually before you knit them all together and run the whole program, which would be integration testing. Now, if you want to test a subroutine on its own, you have to create an environment where it will run just on its own, and that's called a test harness. You would just create a very short program. For example, if I was testing startup and nothing else, I might create a little short program that calls startup. Startup would read the ticket prices file, and then the test harness could just show on the screen, could just print out on the screen the details that it has read from the file. And that would test your startup routine. You could also make use of stubs, which we talked about before when we were developing the initial main loop for the program, where you take your functions and strip them down to be just a single print statement to the screen and nothing else. So if you have any difficulty getting your whole program going, you could take the guts out of a function, set it aside in a file, keep it safe, turn your function into just a single print routine, and test everything else. So you're simplifying the overall program in order to work out where things are going wrong. Now you'll want to produce a detailed test plan. The layout for that is suggested on page 16. And you want to make sure that you've thought about what they expect. Hello, sorry for the interruption there. Testing, which you'll see on page 16, you want to make sure that you've stated what you expect to see when you run the test, and then you must record what you actually see. And it will look good in terms of your evidence that you're going to present, not for this because this is a practice one, but for your assessment project. If you can show that you've been through certain tests have failed, you've corrected things, and then you've present test results where things are corrected and working well. If you already favour another test plan layout that you've used in any of the other bits of the course, that's fine, you can use those. You should aim to test every path in the software, and you should specify your expected outputs. When something unexpected happens in your testing, you can use that as an opportunity to add more tests to your test spec, and your test spec will just become more and more comprehensive, and you'll be glad of that down the line, because at some future point when you have to change your software, you'll have that really comprehensive test plan available just to pick up and use. Good luck with your testing. It's a really good skill to learn, and it's one that you can always improve on. That was outcome 3. Let's finish off by looking at outcome 4, which is documentation. So you are asked to document an event-driven program. First of all, user help. Most of the help you're going to give the user will be on the screen. The smart way to try this out would be try your program out on other people. Pay attention to any place where they're not sure what to do, because that means you need to improve the advice you're giving to them in your prompts. So tune in to where people are clear and using the software well, and where they're hesitating because it's not clear. Your aim is to make a user interface where no one needs additional help, and that usually takes a bit of work. If the user gives invalid input, make sure you give a little bit more help in your error message. You can show that you've considered user help by commenting it in your code. And the example I've got here is in the main program, we put out the prompt for the number of stages of travel. And then in the ticket sale handler, the number of stages gets passed in to the ticket sale handler, and it checks for the valid values. And you can see the comments here. It comments that it's about to validate the number of stages, then it comments that it's going to advise the user of the valid values. And it gives a helpful message telling them what the valid values were. Now, you're asked to create a user guide with the following titles in it. It really can be quite brief, but you do need to just write a little bit to introduce your system and explain its purpose. The system requirements is straightforward, as you'll see on page 17 of the workbook. It's just Microsoft Windows and Python idle are the system requirements for running your program. And then you can look at, in terms of documenting operating instructions, you can look at the user prompts in your program and just describe what the user is being asked to do in each case. So a basic user guide. And then a technical guide. Now this one's really easy because pretty much the text all exists for this. The project brief you should be able to find at the start of the workbook, just where it describes what you're being asked to write. Your specification document can flesh out that description to just explain how the system will operate in a little bit more detail. Your design document, you can include your user interface designs that you did in PowerPoint. You can include the design of the data files, which we saw laid out in a table explaining the content of the data files. And you can also explain the events to which your main loop is going to respond. Then you can put your program code listing in, so make sure you've got lots of good comments in it and copy and paste that into Word. And lastly, you can include your test spec. Now, if your test spec is in landscape orientation, you can, and if you're not sure how to change a Word document to let you put a landscape document in, you can give me a call and I can explain that. So that's the technical guide. And that's it. That is the documentation that you're asked to produce from your project. Now, this whole Ticket Machine project was designed to give you practice in everything that you will need to complete the assessment for the event-driven programming module. The assessment is in the workbook from page 18 onwards. It's a separate project that is of exactly the same level of complexity, and all of the things that I've guided you through doing for the Ticket Machine project should have prepared you for being able to tackle that project. I hope you enjoy writing it. Don't hesitate to get in touch if you need any help.